Here's a belief worth killing. That to connect an AI agent to your tools, your files, your APIs, you have to write custom glue for every single pairing. Look at this picture. 3 agents, 5 tools, and a tangle of hand-built connectors in red. One for each pair. It's brittle, it's duplicated, and nobody can keep it alive. There's a much better way, and it has a name. That name is the Model Context Protocol, MCP. Watch what it does to the mess. It collapses that tangle into a single clean hub. One open standard for how agents and tools talk. So any agent can talk to any tool. People call it the USB-C of AI, and that's exactly the right picture. One socket, and everything just plugs in. This hub is the picture we'll build on for the rest of the video. So let's name its parts now. In the middle, the agent runs an MCP client. Out on the ring, each tool runs an MCP server, a database server, a GitHub server, a Slack server, and so on. And between them, one standard connector, the same plug every single time. Keep this shape in your head. We'll reveal it piece by piece. And by the end, light up a real request flowing all the way through it. First, the problem MCP exists to solve, the integration hairball. Before any standard, connecting an agent to a tool meant writing bespoke code for that exact agent and that exact tool. Look again at the red lines. Each one is a separate, hand-built integration. The coding agent needs its own code to reach the database. The research agent needs different, incompatible code to reach the same database. None of it is shared, and every one of those lines is yours to write, yours to debug, and yours to keep working forever, even as both ends keep changing under you. And the real horror is the math. With N agents and M tools, you don't get N plus M connectors, you get N times M. 10 agents and 10 tools isn't 20 integrations to maintain, it's 100. Add one new tool, and every single agent needs fresh code to use it. That explosion is exactly the trap MCP was built to kill. The fix is one simple idea, borrowed from a cable. Think about USB-C. It replaced a whole drawer of proprietary cables with one shape. MCP does the same thing for AI. Define one open standard for how agents and tools talk to each other, and the N times M tangle folds down into a clean hub. The crucial shift is this. The tool no longer cares which agent is calling it. It only cares that the caller speaks MCP, which means you build the tool once. Wrap your database, your API, your files behind a single MCP server, and you're done. Now Claude can use it. An IDE can use it. Your own custom agent can use it. Anything that speaks the protocol picks it up, with no new glue ever. Compare that to the old world, where a new agent meant rebuilding every connection from scratch. Here, you write the server once, and plug it in everywhere for free. Now let's open up the hub, client, server, and the protocol between them. The host, that's your agent application, spins up one MCP client for each tool it wants, and each client holds its own dedicated link to one MCP server. Under the hood, it's nothing exotic. Plain structured messages in a format called JSON-RPC, going back and forth. The host runs the clients. Each tool runs a server. That clean split is the whole protocol, right there. So what does a server actually expose? 3 kinds of thing. Tools. The actions it can take, like send an email or open a pull request. Resources. Data it can read out, like a file or a database row, to feed the model context. And prompts. Ready-made templates that show the agent how to use this server well. Notice the shape of that. Actions, data, and guidance. Everything an agent needs to put a tool to work. So the moment a client discovers a server, it instantly knows what that tool can do and exactly how to ask for it. Let's trace a single request all the way through the hub. Watch the middle. First, the client asks a server a simple question. What do you offer? The server answers with its list of tools. Now the agent picks one, say, open a pull request, and the request travels out along the standard connector to that server. Notice what did not happen. The agent never hard-coded that call. It discovered the tool first, then invoked it. The agent sends the call, the tool's name plus typed arguments. The server runs it, hitting the real system on the other side. And then, watch the green dot come home. That's the result returning. Not a blob of loose text, but a structured value the model can actually act on. Request out, result back. All of it riding one protocol. That round trip is MCP in a nutshell. Step back. Why does this matter so much? The deep win is decoupling. Because the agent only ever speaks MCP. It knows nothing about any tool's private API. Swap the database underneath, upgrade the server, add a brand new tool to the ring. The agent's code does not change one line. You build the connector once and reuse it across every agent you will ever write. That's the whole promise. Build once, reuse everywhere. And once a server works for everyone, something powerful happens, an ecosystem. The community builds servers once and shares them. So connecting your agent to GitHub or Slack or your favorite database is often not a coding project at all. It's picking a ready-made server off the shelf and plugging it in. Thousands of them already exist. Every team that wraps a tool in MCP makes it instantly available to every agent on Earth that speaks the protocol. That compounding, shared library is MCP's real superpower. Last, let's place MCP in the bigger stack. An agent really needs to talk in two directions. Down to its tools, its database, its APIs, its files. That's vertical. And that is MCP's job. And across two other agents, handing work to a peer. That's horizontal. And that's the job of protocols, like a tour, agent to agent. They sit on different axes. So they stack together. They don't compete. So when you hear MCP versus A to A, treat it the way you treat USB versus Wi-Fi. They're not rivals. They do completely different jobs, and a serious system uses both. MCP gives a single agent hands to reach its tools. A to A lets whole agents work together as a team. Different layers of the same stack, each solving its own problem. One last thing. A few habits for using MCP well in the real world. You might ask, how is this different from plain function calling? With function calling, you wire one tool into one model by hand in that app's own format. Handy for a single case, but do it across many agents and many tools. And you are right back in the n times m tangle. A shared protocol turns that into n plus m. Write the server once, and any MCP client can pick it up with no changes on either side. That is the whole hub collapsing back into view. So, when would you still handroll a tool yourself? When the job is a tiny one-off, buried inside one app, or when you need something the protocol cannot yet express. Otherwise, reach for the standard and let the ecosystem do the heavy lifting. Let us make the round trip really click. In 4 beats. 1. Connect. The client opens a link to the server. 2. Discover. The server lists the tools it offers. 3. Pick and call. The model reasons about which tool fits the task and sends it with typed arguments. 4. Result. The server runs it and hands back a structured value, which the model folds into its next step. Notice the model never memorized any tool in advance. It asked what was there, reasoned, then chose. That discover then call rhythm is exactly what lets one agent work with tools it has never seen before. One real caveat before you go. That same convenient socket can expose tools that delete files, send messages, or move money. So a server is not something to trust blindly, especially one you didn't write. Scope each tool to least privilege, so it can do only what it genuinely must. Put real authentication in front of anything sensitive, and prefer asking the user to confirm before a risky action runs. And here is the subtle one. Treat a tool's output as untested input. Text coming back from a server can itself carry hidden instructions, quietly trying to steer your agent into doing something you never asked for. Never just obey it. The convenience is the whole point of MCP. But a careless, wide-open connection is exactly where the risk lies. So that's MCP, end-to-end. One standard, any tool. An MCP client lives in the agent. An MCP server sits on every tool. And one connector runs between them. Discover what's there. Call it. Get a structured result back. Build that connector once, and the entire ecosystem snaps in. So the next time you wonder how an agent reaches the real world, you'll see this hub, the hairball gone, one universal port in its place. Build a tool once, and every agent can use it. That's the USB-C of AI. Subscribe for more such intuitive videos.